Hello, I am Anshul and let's talk about modulus. Modulus of x or absolute value of x is nothing but x without a negative sign. Basically ये जो mod है ये एक ऐसी गली है जिसमें से जाकर पाप धुल जाते हैं. Positive numbers remain positive but negative numbers become positive. So mod of minus 5 is 5. Mod of 5 is 5 only, no change. We can also say mod of x is distance of x from the origin. So mod of minus 7 is distance of minus 7 from 0. 0 is the origin and the distance is never negative, so it will be 7 only. Now this is how we can define mod x. See, if the number is positive, it will remain positive, no change there. But if the number is negative, we will place a minus sign to cancel the negative sign of the number. Now instead of x, let it be any expression, the same rule will apply. If the expression inside the mod sign is positive, it will remain positive, it will come out as it is. And if it's negative, it will come out with a negative sign. And if you are clear with this part, you can solve any question based on modulus. So we'll start with a few basic questions. Two approaches that we can take. One is this one. Mod x is x if x is greater than or equal to 0 and minus x for x less than 0. Second approach is distance from origin. Mod x is distance of x from origin. Mod x is equal to 3. Mod x is x for x greater than equal to 0. So this will be x is equal to 3 and mod x is minus x for x less than 0. So this is minus x is equal to 3 for x less than 0. Basically minus 3 and 3 are the two values satisfying this. Talking distance wise, distance of x from origin is of 3. On number line we can go 3 units right as well as 3 units left. Distance is 3 only. Points we will be getting are minus 3 and 3. For inequality, we will again write the two conditions. Pretty similar, right? But we have an inequality sign. So we will have a range of values for our answer. Minus x is less than 3. Transpose the minus sign and the inequality sign will change. X is greater than minus 3. Our range is from minus 3 to 3. Both not included. If there was a less than or equal to sign in this question, then we will include minus 3 and 3 in our answer. For now, minus 3 and 3 are not included. Now distance wise, this means all the values of x for which the distance from origin is less than 3 units. Now this is origin. And we are talking about all these values. Now if the question says how many integral values of x satisfy this inequality. Now on number line you can see 5 values. We are not counting minus 3 and 3 as there is a less than sign and not less than equal to sign. So how to count the integral values from minus 3 to 3 directly? We have to exclude minus 3 and 3 as we don't have a less than or equal to sign. So basically we have to count integers between minus 2 to 2 both included. Right? That would be 2 minus minus 2 plus 1, that is 5. 5 integral values. Understand this way. Integers between 6 and 9 both included are 6, 7, 8 and 9. 4 values. But 9 minus 6 is 3 only. So we add 1 more to get the actual count. 9 minus 6 plus 1. That would be 4 values. So here in this case, it is 2 minus minus 2 plus 1. That is 5 integral values. For mod x greater than 3, again two conditions. Mod x will become x for x greater than equal to 0 and minus x for x less than 0. From case 1, our answer is x greater than 3. That means x lies from 3 to infinity. And second one is x less than minus 3. That means x lies from minus 3 to minus infinity. Now x can lie anywhere, either in the first region or in the second region. Both will satisfy. In first region or in second region. For or, we use union. This is our answer. This cannot be first region and second region. Understand this. This is first region or second region. It cannot be first region and second region, because x lying in any of the region will satisfy the inequality. It doesn't have to be in both the regions simultaneously. So when you say or, it means union, and means intersection. Now this is how you remember it. Union sign slightly looks like R in OR, and intersection sign slightly looks like A in AND. So this is how you remember this. When there is OR, you use union, and when there is AND, you use intersection. On number line, we are looking for values of x with distance from origin greater than 3 units. In these regions, the distance was 3 units. In this region, the distance was 3 or less than 3 units. So what we want is everything outside this region, from minus 3 to minus infinity and from 3 to infinity. Now tell me, what's the distance of 5 from 2? You will do 5 minus 2, right? And distance of x from A will be mod of x minus A. Modulus, because distance cannot be negative. So it is mod of x minus A. Now we just want the magnitude. So in this next question, if it is given mod x minus 2, then it simply means distance of x from 2. The origin in this case will be 2. And mod x minus 2 is less than 3 means distance of x from 2 is less than 3 units. So on number line, 2 is our critical point which we are concerned about. Distance from here should be less than 3 units. So we can go 3 units to the left as well as 3 units to the right from here. Right? Now this is our range from minus 1 to 5. Both excluded, as there is less than sign and not less than or equal to. Number of integers satisfying this inequality will be, well, we have to exclude minus 1 and 5. So we'll count from 0 to 4. 4 minus 0 plus 1, that is 5 points. Basically, when it comes to number of integral solutions, these two questions, mod x minus 2 is less than 3 and mod x minus 5 is less than 3, are same only. If it is mod x minus 5 is less than 3, number of integral solutions will be 5 only. Even this third one is also same, as number of integral solutions depend on distance from center, no matter where the center is. Got it? In first case, center was 2 and we went 3 units left and 3 units right to cover 5 integral points. In second and third case, centers are 5 and 0, but we'll go same 3 units left and 3 units right in both the cases, covering 5 integral points again. So if it is a question of finding number of integral points, all these 3 questions, all 3 questions are same. Now these points will be different in each case, but number of integral solutions will be same, as it depends on distance and not the critical point. Next question. Take 2 common and transpose it. This can be further written as x minus of minus 3 by 2. Basically the center or the critical point is minus 3 by 2. And we have to look for points which are at a distance of 4 units from minus 3 by 2. Point on the left will be minus 3 by 2 minus 4, that is minus 11 by 2. And on the right will be minus 3 by 2 plus 4, that is 5 by 2. So answer is minus 11 by 2, comma 5 by 2. Simple, right? Now the center or the critical point could be found by simply equating whatever is inside the modulus sign to 0. 2x plus 3 is equal to 0, x is equal to minus 3 by 2. That is our critical point. Now if we have a less than or equal to sign, we can write the answer directly. Minus 11 by 2 to 5 by 2, both included. Another way to look at it can be when we have a mod x less than or equal to 8, we said x lies from minus 8 to 8, right? So in this case, 2x plus 3 will lie between minus 8 to 8. This part is important. If there is mod x is less than a written somewhere, that simply means that x will lie between minus a to a. So here we have 2x plus 3 is less than equal to 8. So 2x plus 3 will lie between minus 8 to 8. Subtract 3 throughout and divide by 2 throughout. 2 is a positive number, so we can divide by it throughout without changing the inequality sign. For greater than sign, it will be minus infinity to minus 11 by 2 union 5 by 2 to infinity, round brackets. A little similarity that we had in quadratic inequality. For less than sign, we got regions between the roots, and for greater than sign, we got regions outside the root in case of quadratic inequality. And kind of similar thing is happening here, right? Next example. Now this is not as simple as mod of something is equal to a constant. For this question, we will go by the standard procedure. This is how we deal with the modulus sign, right? We will open mod 2x minus 3 similarly, forming two cases. First one is if 2x minus 3 is greater than or equal to 0. That means x is greater than or equal to 3 by 2. This is the condition for case 1. This is the umbrella under which we are going to solve this case further. And no matter what solution we get, this condition has to be followed. Now if this condition occurs, if whatever is inside the mod sign becomes positive, then we can simply remove the mod and write our inequality as 2x minus 3 is less than x minus 1. This will give x is less than 2. This is our solution from case 1. And our condition for this solution is x is greater than or equal to 3 by 2, which has to be followed. So our solution 2 will have to follow this condition, right? So we'll take the intersection of solution with our condition. X has to be greater than or equal to 3 by 2 but less than 2. X belongs to 3 by 2 to 2. 3 by 2 included and 2 is excluded. Now this is solution 1 that we have got. Same thing we will do in case 2. We will obtain a condition and a solution. We will take their intersection and obtain solution 2. Case 2 is when whatever written inside the modulus sign is negative. If 2x minus 3 is less than 0, 2x minus 3 is less than 0 means x is less than 3 by 2. This is the condition. Now in this case, mod opens with a negative sign. We have minus of 2x minus 3 is less than x minus 1. This gives x is greater than 4 by 3. Take its intersection with our condition, x is less than 3 by 2. This is our second condition. So we get a range of x as 4 by 3 to 3 by 2. This is our solution 2. Now listen carefully. X can lie in solution 1 or solution 2. In both the cases, it will satisfy the inequality. You can verify this by putting values. But the point is, solution 1 or solution 2, x can be anywhere. We have to take union because there is or involved. So our final answer is x belongs to 4 by 3 to 3 by 2 union 3 by 2 to 2. Now you can see this 3 by 2 is also included in our range. We have a square bracket at 3 by 2. So we can write our answer as x belongs to 4 by 3 to 2. I hope you are clear with this method. Any modulus question can be solved like this. There are two conditions for opening a modulus sign. Make two cases for them. For case 1, take condition 1, that is whatever is inside the modulus sign is greater than or equal to 0. Now if this happens, we can simply remove the mod sign directly. Now solve the inequality and obtain a solution. Take intersection of this solution with condition 1 and get solution 1. Similarly, obtain a solution 2 and finally take solution 1 union solution 2. Got it? In one case take intersection, in second case take intersection, and then finally in both the cases take union. That's all for this video. We saw basics of modulus, how to open a modulus sign, and we also saw modulus as a distance from a given point. Thank you.